Soldering is a process for joining metal surfaces. In this process, the metal surfaces are heated. When solder is applied, it melts and unites with the metals to be joined. Solder, an alloy or mixture of metals, increases the mechanical strength and electrical conductivity of the joint and protects it from corrosion. In all soldering, the metal surfaces must be clean. However, if clean surfaces are simply heated, oxygen from the air unites with the metal and forms a coating. When solder is applied, it melts but merely lies on the coating. If a cleaning agent known as a flux is applied, it removes this oxide coating, permitting the solder to contact the metal. However, if the clean metal surfaces are first coated with flux and then heated, oxides do not form. Now, when solder is applied, it flows along the surfaces and into the seam. A magnified cross-section of the metal surface shows that metal actually dissolves in the hot solder, forming a new alloy of solder and metal. This requires more heat than just enough to melt the solder. The heat is applied to the metal, and it must be applied long enough to permit the solder to flow into and fill the entire joint. This is sometimes called sweating in. Here is an assembly requiring a variety of soldering operations common to all types of hand soldering. The airtight waterproof seams of the container are soldered, also the circuit wiring inside, as well as the subassembly of coils. Most of these soldering operations are done with electric soldering irons. The various sizes are rated in watts according to the amount of heat they deliver. Some have a special grip attached for easier manipulation. A 1 to 200 watt iron with a long, where the workpiece is light enough to be easily handled, a holding fixture may be used for the iron. Clamp the iron rigidly in position at an angle convenient for manipulating the work. Then plug in the iron. As the copper tip heats, it oxidizes. This oxide coating is a poor conductor of heat. Its formation must be prevented by tinning the tip with solder. For convenience, solder comes in wire of various sizes, which may have a core or center containing a flux. This is called cord solder. Cord solder may be used for tinning the iron as well as for soldering joints. When the end of the solder touches the hot metal, the flux melts first, cleaning the surface. After the excess solder and flux are wiped off, a bright coating of solder, which does not oxidize, remains. Next, prepare the work itself. Here, enameled wires are to be soldered to previously tinned terminals. First, clean the enamel off the wire. A fine grade of sandpaper may be used for this purpose. Make certain that all the enamel is removed, but avoid damaging the wire itself. To form perfect joints rapidly, these cleaned wires are now tinned. To do this, build up a small pool of solder on the tip of the iron. Then draw the cleaned wire through this, touching the cord solder to the wire with just enough pressure to maintain an even flow of flux and solder. For electrical wiring, rosin flux or rosin cord solder is used. Rosin, unlike salt or acid fluxes, will not corrode the work. Although soldering will strengthen and protect the joint itself must first be made as mechanically strong as possible. 1.5 or 2 turns are sufficient to anchor this wire. Leave just enough slack used for insulation. Slip it over the wire before fastening. When clipping off excess wire, be sure the clipping does not fly into your eye or drop into the assembly. The joints are now ready for soldering. A plate glass shield protects the eyes from fumes as well as splatter. Test the heat of the iron by touching the tip with solder. The flux and solder should melt instantly, but the rosin should not char or burn. Now place the joint to be soldered so that the wires lie flat on the face of the tip. Feed solder to the iron for a little pool or trough to aid the conduction of heat. Then touch the solder to the wires. Avoid an excess, but make certain there's enough to flow evenly throughout the joint. Notice that this wire terminal and wire are already tinned. Pre-tinned copper wire is used in most electrical circuit assemblies. The terminals or lugs are also tinned before assembly. However, these terminals should be carefully checked to see that none are dirty or corroded. If any seem dark or dull, clean them with a bit of sandpaper. Terminal, advantage may be taken of the hole to anchor the wire at the tip. Thread the wire through the hole and around the lug, then pinch it tight. Sometimes, where 3 or more terminals are to be joined, a single long length of wire makes a neater, stronger fastening than several short pieces. For an electrical circuit as simple as this, most of the connections are made first. Then one joint after another can be soldered in rapid succession. During soldering, the assembly must be held firm. For this purpose, a holding fixture may be used, or with a fairly heavy piece like this, a felt pad underneath will provide enough friction to prevent the job from slipping. For some small jobs, gloves are not needed when using the iron. Safety glasses, however, should always be worn to prevent any possible injury to the eyes. A cage should also be provided for the hot iron. Never leave an iron on the bench. No one can tell whether it is hot or cold, and accidental burns may result. Many operators prefer an iron with a pistol grip. Before using the iron, clean the tip on the canvas wiping pad. Be sure the iron is tinned. Then test the heat. In soldering vertical terminals of this sort, first place the tip as flat as possible against the joint to heat it. Then form a trough between the iron and the lug. Melt solder into this trough. Now press the tip flat against the terminal. The entrapped solder will conduct heat efficiently so that solder applied to the other side will flow evenly. Apply just enough to cover the joint. Should there be an excess, it may be picked up on the tip of the iron and wiped off on the canvas pad. In soldering horizontal terminals, the tip of the iron is usually applied to the upper side of the terminal. Flow solder between the iron and terminal to conduct heat. Solder applied to the top of a heated terminal will flow around the joint to the underside. Slide the iron off the terminal, don't lift it. Sliding leaves a smooth joint. When all joints previously fastened have been soldered, the balance of the wiring and parts are firmly fixed in position. Then these joints are soldered. The addition of these resistors with stranded wire leads will complete the circuit assembly. The resistors are slipped into the spaghetti insulation and anchored to the specified terminals. Wrapping the wire securely around the terminal assures a firm connection. In soldering joints like these, be careful not to melt or burn either the spaghetti tubing or the insulating material at the base of the terminal. Return the iron to its safety cage as soon as you are through using it. Then check all joints carefully to make sure none have been overlooked or poorly soldered. Sealing these assemblies into cans requires additional soldering operations. The seams have already been spot welded for mechanical strength, but they must be sealed with solder. This is most easily done with a flame or torch. Adjust for a fairly full flame. When soldering with a torch, always wear both safety glasses and gloves. Use a holding fixture for the work. As it is possible to clean these pieces thoroughly when finished, an acid flux may be used. Brush the flux over the surrounding area and into the seam. Now heat the seam thoroughly with the torch. Keep the torch moving so that no one spot is overheated. Then apply the solder along the length of the seam. Keep the metal heated with the torch so there will be ample time for the solder to sweat into the seam. Here's the outside of the seam. Notice the flux creeping out of the seam, followed by the solder itself. Make sure the work is held at an angle so that the seam itself forms a trough. Then the solder will flow down into and fill the seam. When all seams are finished, inspect the job to be sure it is perfectly sealed. Whether acid or rosin flux was used, these cans must be thoroughly cleaned before use. As the covers for the cans cannot easily be cleaned, a rosin flux or rosin core solder must be used to prevent corrosion. The nuts and bolts which support the brackets are soldered first. The workpiece is placed directly on the table. No special holding fixture is necessary here. As the heavy metal of the cover will conduct heat rapidly away from this joint, the area surrounding the nut and bolt is heated first. Then the tip of the flame is directed on the nut. Apply rosin core solder to the nut and bolt. Melt enough solder to flow completely around the nut. Sweat the solder in, but avoid overheating. Rosin flux will burn. After sealing the nuts, position the terminals. Place a preformed ring of solder over the hole. Then slip a terminal through it. The copper collars now rest on the solder rings. Apply heat to the surrounding area as before. Now direct the tip of the flame to both the cover and the copper collar. The solder melts and flows throughout the joint. When the finished covers have been assembled to the wired circuits, these units are placed in the clean cans, ready for the final sealing of the seams. For the two side seams on this particular job, a fixture is used which not only keeps the work from slipping, but holds the seam firmly together. Tapping the cover down gently brings it even with the sides of the can. A file is used to even up and clean the edge of the can. The cover is roughened and cleaned vigorously with a stiff wire brush. The surface is then coated with a rosin alcohol flux. The heavy metal of this can dissipates heat rapidly. If the seam is to be sealed with an iron, the iron must be a large one, or 2 irons may be used alternately to speed up the work. In an operation of this kind, start at the end of the seam farthest from you, holding the iron flat against the work. Feed the rosin cord solder to the side of the tip. It will then flow between the iron and the metal surface, aiding the transfer of heat. A scrubbing motion of the iron may help in filling the seam. Excess solder may be cleaned off the surface with the flat end of the file. Do not unclamp the holding fixture until the seams have cooled sufficiently to set the solder firmly. The 2 end seams are sealed with a flame. The can and contents have been placed upside down on the bench in such a position that the solder flows down into the seam. In this way, a pool is formed inside which provides an effective, airtight, waterproof seal. In the soldering of this assembly, procedures common to all types of hand soldering have been followed. First, the metal surfaces are cleaned so that the solder may contact the metals to be joined. To increase mechanical strength, the joint is sometimes fastened by bending and pinching, or by wrapping, or even by spot welding. Strength should not depend on solder alone. Finally, heat is applied, then solder. Whether a flame is used or an iron, the work is heated first, then the solder is applied, and the heat is continued just long enough for the solder to flow throughout the joint.